May 2015, paper 2, number 4. The geometry one. Everybody just loves this one. Now, geometry ones that deal with, you have your units sitting there, you are going to get unit penalties if you do not show your units. So you want to make sure you show your units on any of these. So we have a triangle, and that definitely is not a right triangle because it's got 110 degrees at one of the corners. Let's see. So this is the little b, little c, little a. I do not have an opposite angle and the side across from it, so I know I can't use law of sine. So I'm going to be having fun with this one. Alright, calculate the total length of the course. I need to find little b. So, I look at my formula chart, which I'm going to find right now because I want to make sure we find this. Alright, I don't have the side across from an angle, so I can't use sine rule. So I'm going to have to use cosine rule. Now this one is set up to find little a if we know big A. Well, I can rewrite that pretty easy. This side and that angle have to be the ones across from each other. These are just the other sides. So if I follow that pattern, need a new page because we're starting a new problem. This is number 4, part A. So, and I might call it little b here, will equal one side squared plus another side squared minus 2. This is times this side times that side times the cosine of the angle across from this one. So I need to check my mode. So you will get points for plugging in to the cosine rule formula. Notice this one's worth 4 points. So using the correct formula, correctly substituting in, and getting the right answer. So let's see. We need to do 700 squared plus 900 squared minus 2 times 700 times 900 cosine 110. And that gave me a really long number. Now remember, that's what b squared is. I would actually show this step. It's not required, but I would want to show my grader everything I can. So I'm going to go up and take the square root of that, because this is what b squared equals. So I get that b is 1315.653975. Notice I'm not rounding. Alright, so I found that side, but it asks for the total length of the course. So the length of the course would be if I added up all 3 sides. So that side plus 700 plus 900. Length of the course would be, and I could write out the entire thing. You could also go to 2,920. But I think I would write out the entire thing. So if I'm using another part, I would be totally correct. Or 2,920. This would actually be the best way to write the answer, both unrounded and rounded. It is estimated that the fastest boat in the race can travel at an average speed of 1.5 meters per second. Calculate an estimate of the winning time. Okay, so they gave us the speed. We know the distance. So we just need to find time. That's easy. Wow. So we would take that answer. So the length, of course, divided by 1.5. This would be acceptable method points, showing this and then in the calculator, just taking that last answer and divide it by 1.5. Notice I'm not rounding it. And that's 19,419. Okay, so 1943.769316, and the speed was in meters per second, because this is in seconds. Oh, they want the answer to the nearest minute. Oh, gosh. Well, each minute has 60 seconds. So if I divide that by 60, I'll find out how many minutes that is. Now it said round to the nearest minute. That would be 32. 32 minutes. Part C. Find the size of angle ACB. Oh, that's nice. ACB. I can now use a sine rule. I know what little b is. So the sine rule says I take little b over the sine of that angle. And I did not have to write it all. I'm just doing that to try to show you that we want to be exact as possible. Equals, and it says find angle ACB. Okay? Look again, ACB. That means that big angle C. So I need to put little c over sine of big C. So I'm going to show you what I can do. I need to cross multiply. So I'm going to take 700 times the sine of that. So 700 times the sine of 110. Oops, I keep forgetting to put the other one. 110 equals 2915.65. And I'm just going to put dot dot times the sine of angle C. Then I would need to divide by that to find out what the sine of angle C is. So I'm going to go ahead and do that. So 700 sine of 110 divided by, now, do you want to retype that whole thing? I don't. Oh, wait. Oh, no. How did I mess up? What did I mess up on? I forgot. I used the length of the course. Oh, no. That's not right. So I'm going to mark through it, and I'm going to put B, which is the correct length, 1315.65. I'll put a dot dot there because it can catch on to that. I'm going to mark that out. 13. So see how you can change if you realize you made a mistake? I wanted to show you that that's okay. People do make mistakes. Now, if you had made that mistake on the test, they'd mark off 1 point for just one part of the substitution. So I want to go back and select that. You can actually arrow up and select the entire answer. So I don't have to type it all again. And 9, 6, blah, 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 blah. Now remember, that's what the sine of angle C is. So to get angle C, we need to take the inverse sine of what we just found. And it says it's 29.9979, 29.9978831 degrees. Rounded to 3 significant figures, that would actually be 30.0 degrees. Because you have to show that you actually rounded to 30.0. Okay, let's see what else we have. To comply with safety regulations, the area inside the triangular course must be kept clear of other boats. And the shortest distance from B to AC must be greater than 375 meters. Ooh, look, that's a lot of information. Well, they're going to walk us through it. D says to calculate the area that must be kept clear of votes. D. Since I've been using these other formulas, I think I'm going to use the area formula from this as well. And it says to take 1/2 A, B, sine of C. Now you could use the angle that we just had, or you can actually, I would go back and do the two sides, the angle in between of the original one. That will be a little bit prettier. So let's do 1/2, 700 times 900 times the sine of 110. So 0.5 times 700 times 900 times sine of 110. So I get that the area is 296,000. That's fine. And that would be meters squared. Because it's area. Let's see. The next thing was talking about the distance from B to AC. So I'm going to quickly on part, let's see, this is part E. So we had, this was A, B, C. I'm drawing my picture on my paper. And then this was approximately 30.0. It's actually a lot longer than that. And we want to find the height here. The height there. This side was 900. That's the hypotenuse. And this would be the opposite. Now, I really want to use the entire thing on C. So, let's see. Opposite hypotenuse, that's sine of 29.9979. That's getting enough, I think, equals h over 900. So I'm going to end up having 900 times that. Now, so 900 times the sine of, where was that angle again? Oh, there he is. Notice how I pulled that in so I have the exact angle. So that's 449.9711645 meters, or 450 meters. Determine whether the course complies with the safety regulations. So we needed that distance to be greater than 375. 450 is greater than 375. So the course is compliant. The race is filmed from a helicopter which is flying vertically above point A. Alright. And then it says we have an angle of elevation from H to B. Okay, so we're now looking at a side view. I would draw a picture. I've got H up top, says right above A, so H is over point A, straight up. Let's just be straight up and down, so that's a right angle. And if we're looking from the side view, we can put B there, that's fine. Do we know the distance between A and B, that was 700. So the angle of elevation, this angle, is 15 degrees. Oh, my picture's really bad, but that's okay. Calculate the vertical height here. Notice that this problem could actually have been done without any of the rest of it. It teaches people to read the whole thing. Opposite, adjacent. Tangent of 15 equals h over 700. 710.15. 187.564. So at least go 187.564 meters, which rounds to 188 meters would be okay too. And that's actually the length AH, if you want to be very specific. The next part says, calculate the maximum possible distance from the helicopter to a boat on the course. Well, let's see. The longest distance. Wouldn't the longest distance be from A all the way to C? It really would. So we have H to A, and then we have A to C, and it says calculate the maximum possible distance from the helicopter to any boat on the course. Well, this is the furthest place, so we could calculate this furthest distance. Well, we have this. It's about 188 meters. A to C was what, 1315.65, whatever it was. Pythagorean theorem. So I would pull this squared plus 1315.653975. I'm pulling from the problem of C above, squared. And that gives me D squared. So I might want to show my method there. I'm going to take 188 squared plus 1316 squared. And so they know kind of my process there. Equals G squared, so G equals, I need to take the square root of what I found. 1328. So rounded to three significant figures, 1330 meters.